Now our next practical is to add two BCD numbers. We have to add two BCD numbers. As usual, I will start from TASM Software. Double click on it on the menu. This program is a seventh program, or we can say seventh experiment that I have already saved. So I will open that with that file name, edit experiment 7.asm. So this is the program to add two 8-bit BCD numbers. Okay. As usual, I have written dot model small and I have started with dot data. In data segment, I have taken two 8-bit numbers, that is each of 1 byte, size is 1 byte. So for that, I have used assembler directive define byte. So with the help of assembler directive define byte, I have defined two variables, number one and number two. For number one, I have given value 09h, which is a 1 byte data. And for another variable number two, I have given value 02h, which is also 1 byte data. And one more thing, I have taken one more variable, which is one more variable result, in which I want to store the result and is of size only byte only. That's why with the help of assembler directive define byte, I have declared that variable result. And I don't know the current value of the result. That's why I put it question mark there. After that, I have initialized the code segment with the help of our three instruction. And dot code indicates the start of the code segment, move x comma add data, move ds comma ax. Now after that, I have taken instruction move ax comma 4 times 0h. Here what I am doing here, I am using AL register to get the number in to get the result in BCD format. I have to use the instruction DAA, that is decimal adjust after addition, and that will operate on AL register only. So to see the changes clearly, I have made AH also 0. So AL and AH combiningly will form AX register. For that purpose, I have initialized this AX register with 0, because currently I don't know the BCD addition. Now first number is moved to the AL register and second number is moved to the BL register. And as usual, I have done 1 byte addition with the help of instruction add AL comma BL. So here now 09h and 02h will be added. We know that 09 plus 02 will be 11, that is B in hexadecimal. The result generated will be available in AL register as a B. But this is the hexadecimal result. We want the result in BCD format. To convert the result in BCD format, we will use the instruction DAA, decimal adjust after addition. So it will operate on AL register only, and our result is also in AL register only. So what we will do, we will execute DAA instruction. Under DAA instruction, whatever data present in AL register, it will be checked first whether it is greater than 9. If it is greater than 9, then 06 will be added to the LSB position. 06 will be added to the LSB position of the data. So here I will add 06 to the 0BH. If I add 06 to the 0BH, I will get the result in BCD format. So what is going to happen there? In AL register, we have 0BH and we are adding 06H. 0B will be written as 4 times 0, 1011. So 1011 stands for B. And we are adding 06H. 0 for 0, we have 4 zeros. 4 times 0. And for 6, we have 0110. After doing the addition, we have the result 0001, which is nothing but 11. So this is our BCD result. So binary coded result. and that result we will transfer to the variable result. With the help of three instruction, we have add the content of we have terminated the program move h comma 4ch int 21h and end. At the result you can see here you will get AL content as 1 that we will see now after execution. But save the file, go to exit, type TASM, file name ext7.asm. There is no error and there is no warning. T-link, file name is ext7.obj file will link now. And next is td, file name is ext7.exe. So executed file will be executed. Click on OK. Expand this plane. Now keep watch here on AX register. We will do the step-by-step execution with the help of key F8. Now see here after the execution of the instruction move AX comma 4 times 0h, the data in X register is 00h. Now out of that, for right side 2 will be the LSB and left side 2 will be the MSB. So here left side 2 zeros indicate the content of AL register and right side 2 0 indicates the content of AL register and left side 2 indicates the content of AH register, higher 8 bits. Now here we will execute the program. First data is available in the AL register and second data is available in the BL register here. After that we will perform the addition. So addition came as 0BH. Addition came as 0BH in AL register. Now we will execute this DA instruction so that it will give result in BCD format. Click on OK. So we got the result in BCD format. 011H, which is content of AL register. So this is how we can find the result in BCD format. Terminate the program. After getting the result, goes on F8 pressing until the termination message occurs. Go to file menu and quit. So this is about 7th experiment, how to add two 8-bit numbers with in BCD format. Now we will move on to next our program, that is finding the largest or smallest of the number. So that is the eighth experiment. I will open it with expt. In that we have two parts. Finding largest and finding smallest. The first part is finding the smallest number from array of 10 numbers. We have array of 10 numbers and there we can find the from that 10 numbers we can find the smallest number. So with the help of title assembler directive, I define the title of the program to find the smallest number from array of 10 numbers, each of size 1 byte. Each of size 1 byte. Now with the help of dot model small, I have defined our dot model assembler directive. Next, we want array of 10 numbers. So I have used data segment and in that I have used variable ARR, which is a byte size. With the help of assembler directive define byte, I have declared that uh, variable. which has 10 elements. Here we have 10 elements, each of size 1 byte. And out of that, this 10 element, the we have to find out the smallest number. And to store the smallest number, I have taken one more variable, small smal, and which is of size byte only, because out of these all numbers, 10 numbers are byte size only. And currently I don't know value, that's why I put a question mark here. After that, I have initialized the code segment with the help of three instructions: dot code, move ax, add data, move ds, ax. After that, we will store the result in whatever small numbers we will find in the register only. We will use that register as a AL. So in AL register, we will store that smallest number among that 10 numbers. So initially, we don't know which is the smallest number. So I will initialize it with the help of 0. And to make the result, to see the result clearly, I will whole word, that is X register, I will make it as a 0. So it will be, I have used instruction move X, 00H. After that, I will use instruction LEA SI, ARR. So here LEA stands for load effective address, of ARR. So effective address of ARR will be loaded into the SI register. So it will, that cursor, or we can say compiler, will come over here. So whatever the effective address of this 80H will be loaded into the SI register. Now what we will do, first we will consider that first number is smallest number, and that we will move to the AL register, because we are storing smallest number to the AL register. Now what we will do, move AL, SI. So first data 80H will be copied into the AL register, Now that we will treat that data as a small element, and we will move that data into variable small. Okay. So what we will do in we go we are going to compare, this 80H with this each number. If we found some smallest number from 80H, then we will store that number as a small number, and that we will store in variable small. If not found, then we will go to the check next number, and we go on checking until this 45H. So total we are having 10 numbers. So we will do 10 comparisons. Okay. For that purpose, we should load the count. So in CX register, I will load the count 0H, 3 times 0H, which is nothing but uh, count of the numbers. So we are having 10 numbers, so count will be 10. So in CL register, the content will be 0AH only, and in CH register, the content will be 00H only. So it will set for the counter. So means first time we will check this 80H will be compared with 90H. This is the first count. After that, the counter will be decremented by 1, as we have checked first number. Okay. Now remaining numbers we have to check it. So this is how we will do the comparison. Now we have shifted the count to the CL register. Now I have written a group of instruction which we have to do. We have to execute repeatedly. Now increment SI. Currently SI is at the point here, 80H. Now it will be incremented by 1. That means it will come to the position here, 90H. Now we will take that 90H into the register AL. So for that purpose, I have taken instruction move AL, in square bracket SI. The content of SI currently is 90, will be copied into the AL register. It will be copied into the AL register. And this AL register content with the content of small variable that will be compared. So that whichever is smallest, that will be stored in the variable small. So here I have used instruction compare small comma AL. So it will be checked whether which number is greater. So comparison is done with the help of 2's complement subtraction. So if here if the carry is generated, if the carry is generated, then it means that now